At 3:42 p.m., 21st October 2025, on the command screen of Ukraine's Strategic Strike Division, an infrared feed from a Horizia EU UAV at 6,200 meters locked on the objective with surgical clarity, the Bryansk chemical plant. This was not an ordinary factory. It was the industrial heart of the Bryansk region, the chemical lung that fed the southwestern front. The complex covered more than 18 hectares. Every week, it produced over 60 tons of explosives, propellants, and specialized feedstocks, the exact chemistry used to build cruise missiles, kamikaze UAVs, and heavy artillery propellants. More than 40% of the propellant consumed in Zaporizhia, Kharkiv, and Donetsk traced back to the nitrate pressing lines inside Bryansk's reinforced concrete workshops. In minutes, a coordinated multi-vector strike, electronic deception, low-level penetration, and Western cruise missiles launched from Ukrainian aircraft would turn the Bryansk skyline into a daytime pyrotechnic spectacle, reducing a Russian defense industry node valued at over $1.2 billion to a burning ruin. From the southwest, roughly 140 kilometers out, two Su-24M crews, call signs Torch 1 and Torch 2 from the 7th Tactical Air Regiment, cut across a radar corridor. They hugged the deck at 88 to 92 m and held 870 kilometers per hour. Each aircraft carried a single Storm Shadow on the center pylon, about 1,300 km longer than 5 meters, occupying the bay between the main gear and the central pylon. Fitted with a 450 Kabroch tandem warhead, a two-stage penetrator followed by a heavy blast, the munition could defeat reinforced concrete beyond 3 meters of depth. The deception phase began earlier at 3:17 p.m. when a swarm of 12 Horizia E electronic decoy UAVs launched simultaneously from mobile rails west of Cherna. They split into small teams and fanned out to create multiple false ingress vectors. One bird climbed to high-altitude reconnaissance at 6,200 km. The other 11 carried radar replay modules that mimicked Storm Shadow radar returns in the 2.9 to 3.1 GHz band, modulated to simulate flight at roughly Mach 0.8 as they crossed the northern air defense perimeter of Bryansk. At least 6 decoys were detected and consumed by short-range defense systems. Pantsir S-1 and SA-15 tore M2 batteries patrolling the industrial ring. That attrition was intentional and operationally acceptable. 5 decoys pressed deeper, continuously broadcasting spoof returns while overlaying L1 over L2 GPS jamming. Over the next 6 minutes, emissions from the surviving UAVs forced the S-400's 92 N6E Gravestone radar at Medadapel to rotate its antenna about 28 degrees off axis and reassign its scan sector to handle localized interference. Regional Air Defense Control automatically reallocated surveillance resources northward, precisely where the spoofed data showed multiple low-level incursions. The result was an overloaded, misdirected Russian picture. From the south, the two Su-24M slipped into the low-altitude radar lane, flying below 90 meters and effectively invisible to the dispersed radar nodes. At exactly 4:10 p.m., with roughly 20 kilometers to the target, both crews prepared for release. And then a technical fault arrived. The weapons bus voltage spiked plus 2.44 volts above nominal, triggering a PWR surge alert. Pilots switched to an auxiliary stabilization circuit, an improvised voltage regulator hand built by Ukrainian engineers from recovery gear. Weapons remained armed and mission capable. Torch 1 throttled back to synchronize with the planned ground radar blackout. Its radar warning receiver reported intermittent emissions, the hallmark of semi-active Russian scans. The Storm Shadow's weapon controller entered inertial standby and confirmed preloaded reference imagery, including thermal signatures, rooftop geometry, vent clusters, and ingress points for the nitrox cellulose processing hall. Torch 2, flying 2 kilometers parallel, reported a backup guidance feed from Horizia E, a real-time electronic map of local jamming that identified sectors masked by Kushuka 4 systems. Then Torch 1's RWR flashed red. A Big Bird S-300 radar had registered a return. Russian reaction was faster than expected. 4 Pantsir S-1 mounts near Gorky slewed west, but failed to acquire the low-flying Su-24s. At 420 minutes and 38 seconds p.m., the cockpit interface confirmed weapon-ready GPS lock. Torch 1's Storm Shadow completed image reference synchronization. Countdown 3 minutes. The missile's skin temperature rose as its pressure regulation systems primed. The turbojet start sequence held on standby. At 4:23 p.m., the release order was given. Torch 1 Storm Shadow left its rail. The turbojet spooled in 1.8 seconds. Control surfaces locked for cruise, and the missile settled at about 880 km/h toward Bryansk's industrial core. Torch 2 delayed its launch by 15 seconds to stagger impact times. A transient current spike of roughly 30 amps stressed an auxiliary feeder. The improvised stabilization rig absorbed the surge and kept the mission live at 423 minutes and 15 seconds p.m. The second Storm Shadow left its rail. It wandered 4 degrees off axis and began its final approach from the southwest. The missile's INS started to record micro-accelerations, continuously cross-referencing against the digital terrain map and keeping its positional error under 5 Encélers. The Su-24s peeled away immediately after release, descending below 90 Manasvers, switching on their self-P protection suites and egressing back toward Polotsk. The Ukrainian Air Battle Coordinator confirmed both weapons had cleared the aircraft cleanly. No interceptions had occurred. Guidance remained stable and GPS integrity held at an acceptable level despite Kushuka-4 jamming. Ahead of them, the 2 Western cruise missiles ran a pre-programmed course. The human phase of the mission was over. From this point, the remaining work belonged to algorithms, sensors, and a flight path that had been baked into the weapon's memory weeks earlier. At 423 minutes and 42 seconds p.m., the first Storm Shadow rode steady at a cruise altitude under 30 Maldiksmert, skimming a sparse tree belt south of Bryansk at nearly 880 km/h. It kept altitude via pressure sensors and inertial updates, wings fully extended. The navigation stack, an INS fused with Turkcom terrain matching algorithms, continuously corrected the flight path from onboard digital maps, allowing the missile to operate without satellite fixes. GPS signals faded as the missile entered the zone masked by the Kushuka-4 emitter positioned a few kilometers from the target. The internal guidance logic continued to run autonomously, holding net navigation error within safe margins. Every 0.5 seconds, the system ingested acceleration updates and adjusted flight parameters via an internal interpolation module. At 4:24 minutes and 17 seconds p.m., the second missile trailed by about 2.5 kilometers, flying on a track offset by 4 degrees and preparing to approach from the southwest. The cross-approach geometry was deliberate, force any remaining point defense systems to split tracking loads. Below the SA-15 battery east of Bryansk still scanned westward, where the decoy UAVs kept broadcasting false returns. The battery had not yet detected any signature from the Storm Shadow duo. At 4:25 minutes and 12 seconds p.m., the first missile overflew the southern substation of the Bryansk complex. Its image-matching routines began to engage. Live frames were compared against preloaded reference data. The M3 building, the nitrate and ethyl centralite processing hall was positively identified. Sloped roof, triple exhaust stacks, steel frame. Batch probability 92.6%. Target lock confirmed. Flight control surfaces trimmed for the final intercept minus 3.2 degrees, optimizing the penetration angle. 6 seconds later, the second missile acquired a secondary target, the Central Administration Block C1, roughly 300 meters from M3. Geometry and structure matched the signatures of control rooms and production line command nodes. At 4:25 minutes and 20 seconds p.m., as both Storm Shadows crossed the edge of the industrial belt, nearby short-range air defense, a Torm-2 battery sighted on the eastern logistics perimeter escalated autonomously to tactical priority. 1. A control console alarm declared anomaly detected. Sector 186 degrees to 204 degrees. Altitude ultra-low. Gun director mount sued toward the alert and switched to combat ready. The missiles were now at about 3.2 kilometers, barely 13 seconds of flight, and at such ultra-low altitude, they only appeared in radar during a handful of sweeps. Twin 30 MND-2A38 guns opened short bursts, while a 57 E6 missile was launched 2.8 seconds after target lock. A hail of shells and the single interceptor followed, but the shot group failed to catch the high-speed, low-flying threats. Fire control radar was momentarily blinded by terrain clutter returns, a common failure mode against pop-up, sea-skimming, or treetop-level targets at speed. The 57 E6, guided by radar, detonated more than 100 inhabitants from its aim point. On the operator console, a final red banner appeared. Weapon locked. Impact imminent. 7 seconds later, the first storm shadow struck the roof of Hall M3 at a -3.2-degree angle. Its tungsten carbide penetrator punched through corrugated sheeting, severed stainless exhaust stacks, and smashed into 0.7 meters of reinforced concrete. Penetration depth peaked at roughly 3.2 mm. The secondary detonation produced a compressive shockwave that collapsed the steel truss work on the second level and drove burning gases into adjacent storage. Chain reactive fires erupted as drums of nitroglycerin, organic solvents, and thermal stabilizers were violently overpressured. Flames leapt more than 40 meters into the sky, a pillar of fire visible from downtown Bryansk over 6 kilometers away. At 425 minutes and 30 seconds p.m., the second storm shadow impacted the C1 administration block at a plus 4.6 degrees strike angle. The penetration point just inside the western eave, where primary control racks and coordination servers were housed. The blast sheared the roof away, destroyed high-capacity switchgear, and triggered catastrophic secondary electrical fires. Electromagnetic transients from the explosion severed remaining command and control signal paths. The plant's coordination system collapsed. At the Bryansk Chemical Plant Control Center, operator screens all flipped to lost feed. System error 504. Telemetry from production lines E2 and E3 vanished. Backup channels could not bring systems online because auxiliary transformers had been destroyed in the second blast. The sub-distribution board on C1's first floor ignited. Multiple main breakers tripped, and temperatures exceeded safe thresholds across chemical storage zones. Within 7 seconds, the entire production control hub, synthesis lines, and auxiliary power station were rendered functionally inoperative on any short-term recovery timeline. At the Russian Military Monitoring Center in Clinty, the plant's control feed went dark only 4 seconds after the second explosion. The signal across the entire network went down, forcing technical teams to switch to backup systems, but the optical switchgear had been damaged by an electrical surge. The connection was completely lost with no possibility of restoration. At 4:30 minutes and 45 seconds p.m., the plant's automatic fire suppression system activated, but water pressure measured below 2.1 bar, insufficient to reach the second level of Hall M3. The blaze ran down to the ground floor, where 16 drums of ethyl nitrate sat unsealed. Fire spread into the adjacent D2 warehouse, which stored raw RDX compound. If temperatures stayed above safety thresholds for the next 90 seconds, thermal auto-ignition would occur. At 432 minutes and 5 seconds p.m., a high-altitude reconnaissance infrared feed confirmed the scale of destruction. The control center, main plant, auxiliary power station, and 2 satellite warehouses had been destroyed. Surface temperatures rose by plus 73 degrees C. Within 4 minutes, a smoke column formed, climbing over 200 meters and carrying corrosive gases, nitrogen dioxide, carbon monoxide, and volatile industrial solvents. By 4:40 p.m., smoke still curled upward as a black pillar over Bryansk. The chemical complex's core had become a tangle of warped steel and crushed concrete. Preliminary assessments, incomplete but conclusive, showed that the primary propellant line was neutralized. At least 2 reactive material depots had detonated. The central control power grid was dead. The ammunition supply chain to the southwestern front was effectively severed. Initial estimates indicated a 25 to 30% short-term drop in RDX output, forcing Russia to redistribute production to its remaining 2 plants. Delivery schedules for missile systems such as Iskander-M, S-300, and Tornado-G were expected to slip by at least 3 to 4 weeks. Propellant supplies for artillery and UAV munitions were disrupted, especially in the Bryansk-Kursk assembly hubs. Without Bryansk's feedstock, ammunition plants in Tula, Kursk, and Belgrade would be forced to halt production almost immediately for lack of material. Iskander-M warheads would remain empty casings awaiting propellant, and the southwestern front's fire tempo would collapse overnight. The strike on Bryansk was not only a technical success, it was a strategic statement. Even deep inside Russia, the most critical links in its military supply chain can be broken if deprived of adaptive layered air defense. The operation compelled Moscow to confront its vulnerabilities while proving Ukraine's ability to execute precision strikes with intelligent, high-accuracy weapons despite heavy jamming and multi-tiered defenses. As dusk settled over the Bryansk skyline, a single monochrome line blinked on the command display in Cherna. Target neutralized. A keystroke followed. Hold posture. Monitor reaction. No one spoke, but everyone understood. The next operation was already set in motion. Music.